Good afternoon, everybody. My name's Justin Bucknell, and I'm with iSIMS UK. I'm a structural engineer by training, and been designing offshore structures for the last 28 or so years, mostly for the oil and gas market. And I'm here today to talk about an innovative new structure called an iJacket, which is a support structure for offshore wind turbines. Originally developed for the oil and gas market, but you'll see as I progress that its application is far more attractive to the wind industry. The market for offshore wind is very large and growing. You can see some statistics on the slide behind me. And although dominated originally by monopiles as the foundation support structures, in other words, single pile structures, as the water gets deeper and deeper for many of the consented new wind fields, there will be a transition to jackets, as you can see. At the cost reduction monitoring framework that was published in 2016, I think this key quote was put into there, that what's really needed to create a sustainable business is innovation in engineering and development of a UK supply chain. And you'll see this particular innovation is very much focused at exactly those two things. Look, first of all, at the innovation in engineering. Without going into the technical details of exactly how it works, suffice it to say, compared to its conventional jacket structure, so its competition, if you like, it's in the order of 30% lighter, so 30% less steel. So that has two major advantages. One is it's less steel. It's obviously less costly to build. When you think there's these things in a region of about 100 tons potentially, and there's up to 100 or more than 100 on any given wind farm. So 30% reduction in steel costs is significant. But it isn't really the main benefit of the iJacket. The iJacket's real benefit is more focused on the ability to develop a UK supply chain. The iJacket has only two components. A conventional jacket structure has literally hundreds of different components. So its fabrication process is complex and takes up an awful lot of space. The whole thing has to be laid out like a jigsaw kit and pieced together and welded together and rolled it up, and takes a lot of space and an expensive quayside location. The iJacket, on the other hand, has these two components, as I say, which in the water depths that offshore wind farms work in are very manageable components. They can be moved, they can be shipped by land, they can be moved by rail or sea transportation. So it lends itself for factory fabrication. You can see this particular slide up above me shows a fabrication partner that we're working with, AAF, up in the northeast of the UK, has identified a site in Blythe, quayside site in Blythe, where they would build an iJacket factory using lean, modern manufacturing technology and techniques to rapidly produce these, the rate, they're estimating out of a single factory at the rate of 3 a week. Currently, best practice for a conventional fabrication of a jacket is around about 1 every 2 weeks. So it's a real game changer in the productivity and the rate of production of these jackets. And obviously that's key to getting the things in the water and installed. Currently, UK PLC struggles to compete for the supply of conventional jackets because they lend themselves to requirements for large areas of land, very intensive on labour, large areas of cheap labour. The largest jacket orders that currently exist for existing wind farms are with yards out of Poland. For obvious reasons, even though they're coming into UK wind farms, they're being shipped all the way from Poland to here. Some of the components that are in those jackets are being fabricated in the UK, and they're being shipped all the way to Poland put onto the jackets over there and shipped back again. So this is an opportunity to generate a supply chain here in the UK. The route to market, I have to confess, I can't read the slide in front of me, so I may have to turn my back. But basically, we've come up with a route that involves doing the developers want to see evidence that it works, and the validation body is DNV-GL. Anybody who knows, they certify almost all the wind farms in the UK. So we've established a project with them to basically go through a full design process and have them certify the design to confirm that it works. In the same time, the same project will also validate AAF's assumptions around the productivity claims that they have over their fabrication process and the costs associated with developing that process. So therefore, at the end of the project, we'll have fabrication drawings for a real wind farm in the UK with real parameters used for the design to demonstrate and certified by DNV to say that it works. We're hopeful that that will then give the confidence to the developers to ideally to allow it to be bid commercially, but more probably to build a pilot either on a demonstration site. There's one up in Blythe, we were talking with them yesterday. There's an opportunity to put some of these onto that demonstration site. I'm being told I'm running out of time, so alternatively, have one slot on a larger wind farm array. So, and once it's demonstrated in the field, if our claims are true, then we expect to go fully commercial thereafter. Thank you very much.